A car stops at two sets of traffic lights. Figure 2 shows a graph of the speed of the car, v meters per second, as it travels between the two sets of traffic lights. The car takes t seconds to travel between the two sets of traffic lights. The speed of the car is modeled by the equation v equals 10 minus 0.4t times ln t plus 1, where t seconds is the time after the car leaves the first set of traffic lights. According to the model, find the value of t. So find out where it's equal to 0. So let's set our equation. So 10 minus 0.4t times ln t plus 1 equal to 0. So either this bracket's going to be 0 or our ln t plus 1 is going to be 0. So what's going to make ln t plus 1 0? ln 1 is equal to 0. So that means t would be 0. What makes 10 minus 0.4t equal to 0? So 10 is equal to 0.4t. So t will be 10 divided by 0.4, which is the same as 5 over 0.2, or 2.5 over 0.1, or 25. So t is equal to 25 seconds. It takes 25 seconds for the car to travel between the traffic lights. Part B, show that the maximum speed, so this is the turning point where dy dx equals 0. The maximum speed of the car occurs when t equals 26 over 1 plus ln t plus 1 minus 1. So it's the maximum speed. So we're going to we're going to differentiate and make it equal to 0. The maximum speed is where the gradient is equal to 0. So let's differentiate. So we have two things multiplied together. When we've got two things multiplied together, we use the product rule. So we can say u is 10 minus 0.4t. V is ln t plus 1. Du dt is just negative 0.4. dv dt is, when we differentiate ln, it goes to 1 over. So that will be 1 over t plus 1. Then we can say that dv dt is equal to v du dx, so minus 0.4 ln t plus 1, plus u dv dt. So these two times together, which will be 10 minus 0.4t divided by t plus 1. The maximum point will be where the gradient is equal to 0. So let's make it equal to 0. Minus 0.4 ln t plus 1 plus 10 minus 0.4t over t plus 1 equals 0. So that's where it's equal to 0. We need to rearrange it to get it into this form. So we want to get t to be the subject, but we can ignore the t with the log. So we need to get these two t's on the same side and get everything else on the other side. We want t to be the subject. So let's add our 0.4 ln t plus 1 to both sides. Make it an equation. So 10 minus 0.4t over t plus 1. Not that it wasn't an equation to start with. equals 0.4 ln t plus 1. Let's get rid of the fraction, times both sides by t plus 1. So 10 minus 0.4t is equal to t plus 1 times 0.4 ln t plus 1. So we have, expanding this, so we've got 0.4t ln t plus 1, and we've got just 0.4 ln t plus 1. That's equal to 10 minus 0.4t. Let's get rid of these 0.4s. So to get rid of the 0.4s, we need to times everything by 2.5. So let's multiply through by 2.5. So 25 equals t. 25 minus t equals t ln t plus 1 plus ln t plus 1. Now we can get these t's on the same side. I'll move them both over to the right side. I'm going to take away ln t plus 1 from both sides, and plus t to both sides. Now I can factorize that t. So t ln t plus 1 plus 1 on the right side, and that's equal to 25 minus ln t plus 1. Divide both sides by this. So t equals 25 minus ln t plus 1 over ln t plus 1 plus 1. So it's not quite in the right form yet. So we want 26 on top, and we want a minus 1 on the outside. So to get us a minus 1, we want to have an ln, a minus ln t plus 1 plus 1. So let's change 25 into 26 minus 1 minus ln t plus 1. So I've just changed 25 into 26 minus 1. And now I'm going to factorize out a minus 1. So on the top, I write 26 minus 1 plus ln t plus 1. So we can see we've got the denominator here. So we can split this out into two fractions. So we can have 26 over ln t plus 1 plus 1. I'll put the 1 in the front like it is in the answer. And it'll be minus 1 plus ln t plus 1 divided by 1 plus ln t plus 1. When you do that, when the denominator and the numerator are the same, we can change it into 1. Divide top and bottom by themselves, it becomes 1. So we have 26 over 1 plus ln t plus 1 minus 1. Part C, with t1 as 7, use the iteration formula to find the value of t3 to 3 decimal places. So that's the first part. So we're going to have t1 as 7. So we're going to substitute in 7. Grab the calculator. So we're substituting in 7 to start with. So 26 over 1 plus ln 7 plus 1 minus 1. So we get 7.443. So that's right, T2 is 7.443. And then we can just change the 7 into our answer. And we get T3 as 7.298. Find by repeated iteration the time taken for the car to reach maximum speed. So keep pressing equals. So that's 7.333 seconds.